Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss how to compare functions. So functions can be represented using words, graphs, tables, or equations. So functions can be represented using words, graphs, tables, or equations. Learning the relationships among those representations can help compare the properties of functions, each represented in a different way. So the slope of a line describes the rate of change of that line. Remember, we discussed this. A slope of a line is the same thing as the rate of change of a line. You can compare functions by identifying the slope. So we're going to compare our functions by identifying the slope. Let's now discuss the steps to comparing functions. Okay, so we have two steps when comparing functions. Step one is you want to identify the slope. So we want to identify the slope. And there's different ways we can identify the slope. We can either use our slope formula or our slope-intercept form. So whenever we're given a table or a graph, we want to find the slope using the slope formula. So we want to find slope by using our slope formula when we're given a table or a graph. And if you recall, our slope is equal, m is equal to y2 minus y1 over x2 minus x1, also known as your rise over your run. So either formula, either way, either method will work. Now we're giving an equation. We want to find the slope using the slope-intercept form. So if we're given an equation, we want to find slope by using the slope-intercept form. And your slope-intercept form is y equals mx plus b. Remember, your m is your slope. So your m is your slope, and your b is your y-intercept. So when we're given an equation, using your slope-intercept form, y equals mx plus b, your m is your slope, and your b is your y-intercept. Also remember, your slope is your rate of change. And your b is your initial value. Your y-intercept is your initial value. So remember that your slope, your m is your rate of change, and your y-intercept, your b, equals your initial value. Our second step when comparing functions is we want to then compare the slopes. So we're then going to compare our slopes to identify what the question is asking us to do. All right, so now let's do an example together, how to compare functions. Okay, let's look at example 1. There's 5 questions in regards to example 1. Let's read the question. 3 trains, A, B, and C, leave a train station at the same time. The graph shows the relationship between time and distance for train A. So if we look here, we have 3 different representations. We have train A, which is a graph, train B, which is an equation, and train C, which is a table. And we want to compare the functions. We want to compare the slopes. So let's first answer question 1. It says, what is the slope of the graph? So they want to know what the slope is of train A. So you want to first identify your coordinates. So let's identify our coordinates. We're going to use coordinate 0, 0, because it's very simple, right on the graph. And then we're going to find where else it hits the x and y axis at the exact same time, which is right here. So it's like a point. And let's write our coordinates down. First coordinate is 0, 0. And our second coordinate is over 2. And then between 40 and 80 is 60. So 2 and 60. And we want to find our slope. We're going to use our formula, m equals y2 minus y1 over x2 minus x1. Remember to label your coordinates, x1, y1, x2, y2. And now replace it, substitute it. My y2 is 60 minus my y1 is 0. My x2 is 2 minus my x1 is 0. 60 minus 0 is 60. 2 minus 0 is 2. And then 60 divided by 2 equals 30. So for the slope of train A of that graph is 30. Let's look at number 2. It says, what does this slope represent? So we just found out that train A is 30 is the rate of change, is the slope. And what is that slope representing? Well, it represents train A is traveling 30 miles per hour. Okay, our hour and our miles. So our rate of change or slope is train A is traveling 30 miles per hour. Okay, so we just identified what this graph is telling us in regards to the slope, in regards to the rate of change, and train A is traveling 30 miles per hour. So now number 3 says the relationship between time and distance for train B is given by the equation above, where x represents hours and y represents your miles. Find the slope m. So now we have train B, which is y equals 45x, and it's an equation. So we're going to use our slope-intercept form. Now, if you recall, it says where x represents your hours, so your x is your input, and y represents your miles. Your y is your output. And the equation is telling us y equals 45x. Okay, we found that equation because it's given to us right up here. So now what is my rate of change? What is my slope? Well, your slope is m. So what's my m? M is equal to 45. So my slope for train B is equal to 45. And that's all you do when you have an equation. You just want to identify the m using the slope-intercept form. Let's look at part 4 to example 1. So in part 4 it says which train is moving faster, train A or train B? How do you know? Well, in number 1, part 1, we found out that train A is moving 30 miles per hour. That's what we found the rate of change or slope in part 1. In part 3, we found out that train B is moving 45 miles per hour. So the question's asking which train is moving faster? Well, train B is. And how do we know train B is moving faster? Because it's a higher rate of change. All right, so train B is moving faster because it's a higher rate of change. Now to number 5. We want to compare the speed of train C to the speeds of train A and train B. Well, we already found the rate of change for train A and B. Now we want to find the rate of change for train C. So in train C, we are given a table. So you want to pick 2 points on that table to find the rate of change. So I'm going to pick the first 2 points. So it's coordinate 3, 105, and coordinate 6 and 210. And we're going to use our slope formula. So we're going to label x1, y1, x2, y2. So whenever you're given a table or a graph, use your slope formula. So our y2 is equal to 210 minus our y1 is equal to 105 over our x2 is equal to 6 minus our x1 is equal to 3. So now 210 minus 105 is 105. And 6 minus 3 equals 3. Now we divide. 105 divided by 3 is 35 miles per hour. And that's for train C. So now it's saying compare the speeds of train C to the speeds of train A, B, and B. Well, we know that train A was 30 miles per hour, train B was 45 miles per hour, and train C is 35 miles per hour. So therefore, train C is faster than train A, but slower than train B. So after we found the rate of change for the table, the graph, and the equation, we wanted to compare the train speeds. And after we compare the train speeds, we know that train C is faster than train A, but slower than train B. Let's do another example together on comparing functions. Example 2 is a bowling alley offers different birthday party packages. Package A is represented by the function C equals 7p plus 5, where C is your total cost and P is the number of people. Package B is represented in the table. So compare our functions. Let's first compare package A. Let's identify what our rate of change is in package A. So in package A, we're given the formula C equals 7p plus 5. C equals 7p plus 5. And remember, when you're given an equation, you're going to use slope-intercept form, which is y equals mx plus b. So when we're given an equation, it's just identifying your slope, your m value. So your m value here is 7. Your rate of change is equal to 7 in package A. All right, so now let's look at package B. In package B, we're given a table. And when we're given a table, we want to use our slope formula. Let's first identify our x and y value. So your number of people is your input, that's your x, and your total cost is your output, that's your y. So let's first pick our coordinates. And our coordinates are going to be 1 and 1250. And our second coordinate is going to be 2 and 19. Comma right there. You want to label your coordinates, x1, y1, your ones, and then x2 and y2. So now you have $19 minus $12.50 over 2 minus 1. 19 minus $12.50 is $6.50. 2 minus 1 is 1. Therefore, our rate of change, or m, is equal to $6.50. So now let's look at part B after we find our rate of changes. If 12 people attend the birthday party, which package will cost less and by how much? So let's first complete and calculate package A. So package A, we're going to use our equation C equals 7p plus 5. How many people are there? Well, there are 12 people. So we're going to substitute 7 times 12 plus 5. So C equals 7 times 12 is 84. And then we're going to add 5. So your cost is equal to $89 for package A. All right, now let's find what our cost will be for package B. And in package B, we're not given an equation. We have to create an equation. And we're going to create our equation with the same slope-intercept form. So we have the cost equals, for package B, our rate of change, our M, we just found out, is 6.5, or $6.50. P plus my B is equal to, well, what's our B? How do we find our B? So how do we find our B value here? How do we find that B? We're going to have to refer back to our table above. Okay, and we just found our rate of change, which is $6.50. So if you look at our table, for every person, we are going up $6.50. We are adding $6.50. And if you recall, your B is your initial value. So your initial value starts at 0. So what would our initial value be if we start at 0? Well, if we're going up by $6.50, we have to go back. We're going to subtract $6.50. So you're going to take your number here That was one person, which was $12.50, and you're going to subtract $6.50 to find your initial. So if I had $12.50 and I subtracted $6.50, it would equal $6. So therefore, my initial rate, my initial start is $6. And remember, your initial value is your B. Therefore, our B is equal to 6. Now we found our B, we can find how much package B would cost 12 people. So you have C equals $6.50 times 12 plus 6. Our cost is equal to $6.50 times 12 is 78 plus 6. Therefore, C is equal to $84. So your cost for package B is $84. Well, what's the question asking us? It's asking us which package will cost less and by how much. All right, so package A is 89 and package B is 84. So what costs less? Which package? Package B by $5. So therefore, package B costs less by $5. And we got $5 by just subtracting the two packages. 89 for package A minus 84 from package B, and that gives us 5. So now what I'd like you to do is the you try section. Please read the problem and complete the you try section to find out which activity burns calories at a faster rate. Make sure you explain, and we'll discuss it in class. Thank you.